Hi, this is a video to help you through the activity on units and dosing calculations. Dosing calculations are one of the most important skills that you're going to learn in this class for your future career as a nurse. So please pay attention and understand that this is a long-term investment in your future. For exams, it will be absolutely critical that you use the proper techniques when calculating and you show all of your work using the technique I'm going to show you here. This technique is called using equivalent units or dimensional analysis. I often refer to it as dimensional analysis. To start, let's talk about units. This table is on your activity, and I'd like you to fill out the English units and the metric units for the types of measurements shown. You can pause the video now and fill out the table, or you can follow along with me. For mass, the English unit that you're used to seeing is the pound, and the metric unit that we use in laboratories and in medicine is a gram. For volume, we measure things in fluid ounces in the English system, and in the metric system, we use liters. Length is measured either in inches or miles, and in the metric system, a meter is used. Energy in the English unit is called the calorie, and notice it has a lowercase c. And energy in the metric unit, or in the metric system, is a joule with a capital J. Temperature is measured in degrees Fahrenheit in the English system and degrees Celsius in the metric system. The abbreviations for all of these units are in parentheses, and you should get familiar with these abbreviations. The metric units are what we will be using mainly in this class and what you will see in a chemistry lab. The English and metric units are used interchangeably in a hospital, and so you should be familiar with both, and you should get familiar with the conversions between one and the other. For now, we will refer to the metric unit as our base units. So when we talk about base units, we will be talking about grams, liters, meters, joules, or degrees Celsius. For the next table, we're going to fill in the abbreviations based on the base unit, gram, meter, liter, or joule. So in this table, the base unit refers to these metric units that we just discussed on the previous page. Degrees Celsius is not usually used in the way that we're going to be talking about here, so we can just look at gram, meter, liter, and joule. The prefix kilo in front of a base unit, like a kilogram or a kilometer, means 1,000 times the base unit. So it has the abbreviation of a small or lowercase k, and it means that it's 1,000 times bigger than the base unit. In this chart, the relationship means that a kilogram is 1,000 times the amount of 1 gram. Deci is represented with a lowercase d, and a decigram is 10 times smaller than a gram, just like a decimeter is 10 times smaller than a meter. A centimeter or a centigram or a centiliter is 100 times smaller than the base unit. It's represented with a lowercase c. Milli is a lowercase m, and micro is a Greek letter mu, lowercase. When you see these abbreviations in front of a base unit, you will know that it means that it's these relationships to those base units. Now this chart can be a little bit confusing. Please realize that it's organized from the biggest units to the smallest units. So a kilogram is bigger than a gram, or a kilometer is bigger than a meter. On the other hand, a decimeter or decigram is smaller than the base unit. Keep this in mind as you answer the first two questions on your activity. Notice that the base unit is here, kilo is larger. And so if I was going to write an equivalency between something like a gram and a kilogram, I would write it like this. I know that the kilogram is bigger than the gram, so that must mean there are many grams in a kilogram. And this is the relationship as far as the equivalent units go. So notice that this can be confusing. And you have to remember that kilogram is bigger than a gram, and so there are many grams in a kilogram. There are 1,000 grams in 1 kilogram, and this is an equivalency. For question 2, you're asked what is smaller, a milliliter or a liter? Hopefully you can see that the milliliter would be smaller than the base unit liter. And therefore, if you were going to write an equivalency, hopefully you can see that there will be many milliliters inside of the base unit liter. So if you were writing the equivalent unit for milliliter, it would look like this. There are 1,000 of the smaller unit milliliters in 1 liter. Equivalent units are going to be very useful for you to do unit conversions or dosing calculations. Number 3 is a very simple example of a unit conversion problem. It's asking you to convert liters into milliliters. The question says, many soft drinks are sold in 2-liter bottles. How many milliliters are in this 2-liter bottle? So what the question is really asking us to do is to convert liter into milliliter. To do this, you need a unit conversion that's going to connect the unit liter to milliliter. And that's the unit equivalency that we wrote on the previous slide, or you wrote in question number 2. 1,000 milliliters is equal to 1 liter. This is the equivalency that will connect you from liter to milliliter. So now you can write this as a fraction and use it to do a unit conversion. If I write my 2 liter and multiply it in a way that liter will cancel, so I'm going to use this equivalency so that liter's on the bottom. When I do this, my units will cancel. When a unit is on the top of the fraction and on the bottom, it will cancel, and that will leave me with this remaining unit. So I multiply 2 liters times 1,000 milliliters per liter, and I get an answer of 2,000 milliliters. This is a very simple problem, but it's important that you understand why we can cross off liters and why we can write that 2 liters is the same as 2,000 milliliters. There are 3 main principles that allow us to do this. These are mathematical principles. And the first one is that a number divided by an equal number will always equal 1. For example, you know that 3 is equal to 3, and therefore 3 divided by 3 must be equal to 1. The second principle that allows us to do these manipulations is this. Any number multiplied by 1 is the same number. For example, 2 liters times 1 is equal to 2 liters. You can multiply any number times 1 and get the same number. Therefore, you could also multiply the number 2 times 3 over 3, because 3 over 3, as we showed up here, is the same as 1. And therefore, we should get an equivalent value at the end. In this case, 2 liters times 1 is 2 liters. The third principle that's going to allow us to do these manipulations is that when multiplied, identical things in the numerator and the denominator cancel. Here's an example. If I multiply 7 over 1, or just 7, by 8/7, 7 in the numerator and the denominator will cancel, and I will get an answer of 8 over 1, or simply 8. So these are the 3 principles that are going to allow us to do unit conversions. Let's look at an example of the first one. A number divided by an equal number is 1. So if 1,000 milliliters is equal to 1 liter, then I should be able to divide one by the other and always find the answer 1. And although it doesn't look like it, but 1 liter divided by 1,000 milliliters is the same as 1 liter over milliliter. Or 1,000 milliliters over 1 liter is 1, because these units are actually the same quantity. In principle, I should be able to multiply a value by either one of these fractions and get the same value at the end. Any number multiplied by 1 is the same number. So if I take 2 liters and I multiply it by this fraction, which I just showed was 1, then I should be able to get the same value at the end. And if I apply this when multiplied, identical things in the numerator and the denominator cancel. If I apply this to cancel out the units that are the same in the numerator and the denominator, then I'm left with the unit that's remaining. So if I multiply 2 times this equivalency, I will get 2,000 milliliters. And this equation should be true, that 2 liters is equal to 2,000 milliliters. We will use this principle throughout the rest of this activity and throughout the semester. This is what we refer to as using equivalent units as conversion factors, and it's also called dimensional analysis. Any units can be used as conversion factors. So you can use 1 kilogram is equal to 1 gram to convert between grams and kilograms. 1,000 milliliters is equal to 1 liter can be used to convert between milliliters and liters. And all of the equivalent units that you see on your activity and in your textbook or in any reference material can be used as conversion factors between the units that are equivalent. Please note, down here at the bottom, I've written for you that conversion factors are assumed to have infinite number of significant figures. So any of the conversion factors that you pull out of your tables or your textbook or your activities can be assumed to have an infinite number of significant figures. You don't need to let those limit your significant figures in your answers. Let's do a problem as an example. This is number 4 in your activity. This problem says that the U.S. recommended daily allowance for adult women are 700 micrograms per day of vitamin A and 15 milligrams per day of vitamin E. How many micrograms are equivalent to 15 milligrams? And which vitamin do you need more of each day? Now, to know the answer to question B, it's important that you are able to directly compare these amounts, 15 milligrams and 700 micrograms. To compare amounts, you need to put them into the same units. So you would either need to convert micrograms per day into milligrams per day, or vice versa, milligrams per day into micrograms per day. Since part A is asking us how many micrograms are equivalent to 15 milligrams, we'll just simply convert this 15 milligrams per day into micrograms per day so that we can directly compare these numbers when they're in the same units. So we're going to convert 15 milligrams into micrograms. And if you look earlier in the activity, we don't have a direct conversion between milligrams and micrograms, but we do have a conversion between milligrams and grams, and we also have a conversion between grams and micrograms based on the charts that we filled out on the very front page of the activity. I can use these two equivalent units in tandem to convert milligrams all the way to micrograms. First, I'll convert milligrams into grams. And then I will convert grams into micrograms. Notice that these numbers, since they're equivalent units, should technically be the same as multiplying 15 milligrams times 1, except that I'm changing the units. So when I do this, milligrams would cancel out of the numerator and the denominator, grams will cancel out of the numerator and the denominator, and I will be left with micrograms as my remaining unit. I set this up purposely. If I accidentally flipped one of these, so for example, if I put milligrams on the top and grams on the bottom, my units would not cancel, and I would know that there was a mistake in my work. But because all of my units are canceling and giving me the unit that I wanted to get to, I know that I'm doing this correctly to get the answer I'm looking for. And so when I write my answer in the correct number of significant figures, I will also write the correct units that I got when I was calculating or when I was doing this dimensional analysis. So now I know the equivalent of 15 milligrams is 1,500 micrograms. Now I know that the recommended dose of vitamin E for an adult woman is 15 milligrams per day or 1,500 micrograms per day. So now I can compare the 1,500 micrograms per day of vitamin E to the 700 micrograms per day of vitamin A. And I can see that women need more vitamin E per day than vitamin A. Let's look at another example. What is the weight of a 125-pound person in kilograms? And so what we're trying to do here is convert 125 pounds to kilograms. So we need a way to get from the pounds unit to a kilogram unit. From your activity, you will be able to see that 1 kilogram is equal to 2.205 pounds. And this is a direct way that you can get from kilograms to pounds. So this is the equivalent unit that we will use to convert 125 pounds to kilograms. You set it up like this. 125 pounds times an equivalent unit, and I purposely put pounds in the denominator here so that it will cancel with the pounds in the numerator. Pounds will cancel. I'm left with kilograms as the remaining unit, and that's what I want. So now when I put this into my calculator, I will put 125 divided by 2.205, and I will get this as my calculator answer. Notice I've written my units. That's important. And I will then round to the correct number of significant figures, and again, write my correct units. If you use this to do every one of the problems in your activity, you will have really good practice for what's to come later on in the semester. Remember to write out all of your work, all of your units, cross off the units that cancel, and circle the units that remain so that you can practice canceling units and using dimensional analysis to help you never make a mistake while you're doing these unit conversions. So now I'll leave it up to you to complete the example problems in your activity. It's very, very important that you do all of them and that you understand well. Eventually, these types of problems should be fun for you. Remember to ask for help if you need it, or if you feel any distress at all while you're doing these problems. And know that the key is available on Blackboard. So don't forget to check your work and make sure you're understanding everything very well.